Hey everyone, and welcome to this next lecture on the conic sections. In fact, this is a continuation of the previous lecture in which we were talking about the parabolas. So we already talked about parabolas that open to the right and to the left. So in this lecture we'll be talking about parabolas that open up and then open down. So if you see this parabola over here, it's pretty much like the previous parabolas that we saw. The only difference is that it is now centered at well, the similarity is that it is once again centered at the origin, that is 0 and 0, and the thing is that it is symmetrical along the y-axis. That means that the symmetry, this y-axis will be the line of symmetry for this parabola, and the equation that defines this parabola is x squared is equal to 4py. Now if you look at this closely, if you look at the previous parabolas that we saw, it's pretty much the same equation that we saw in the previous parabolas. That is, since it is opening up to the positive y-axis, it will resemble in the parabola that opened to the positive of the x-axis, that is 4px. So in the previous we saw that this was y squared is equal to 4px, y will be the subject and 4px is the equation of this parabola that opens to the right. Just like that, this parabola will have some similarities with it. One thing that's going to change is, since it is now symmetrical with the y-axis, its subject is going to be x. So instead of y squared we have now x squared over here. The two similarities that we have is the number 4 and p, and y will be over here instead of x. Over there it was x squared is equal to 4px, y squared is equal to 4px. Now we have x squared is equal to 4py. That is the only thing. If you look at these two parabolas, you would see that there are many similarities in between them, because the only main difference that arises in the direction of the parabola, and the reason why there are these differences is because of where the line of symmetry lies and the direction in which this parabola opens. Now the properties of the parabolas are the same as that one. I mean, you have a parabola that's centered at 0 or 0. P is distance from the vertex of the parabola to the focus or the diatrix that we already discussed. This makes the coordinates of the focus is equal to 0p. Equation of the diatrix is going to be negative y. The equation of the diatrix is y is equal to negative p. Now if you look at these 2 points over here, the coordinates of the focus is 0p. But what does that mean? If it is 0, the first number of the coordinate is 0, that means it lies on the y-axis, where the x-axis x values are 0. So it's 0p means it would be someplace over here, p being a value on the y-axis. Now we know what the diatrix is. Diatrix has to be a horizontal line somewhere over here, so we're going to represent that with the value from the y-axis. So that is why it is saying that the focus point would be 0 comma p, and the diatrix is going to be y is equal to negative p, because you know it has to be below the x-axis. So that's why, because the center is over 0 comma 0, so the diatrix has to be below this, so that we would have the value of the diatrix to be 0 comma y is equal to negative p. The axis of symmetry we already talked about it. The axis of symmetry is x is equal to 0. What is x is equal to 0? Once again, the y-axis. I said before that the axis of symmetry is the y-axis. Of course, I didn't say x is equal to 0, but that's the same thing. You should already know that. So moving on to the next parabola, which is the parabola that is opposite to this one, that parabola that is centered at 0 or 0, that has a symmetry of x is equal to 0, which is the y-axis, but it opens down. Now if you look at this, the same difference from the previous one, which we already saw. In the previous one we saw a parabola that opens up. This is a parabola that opens down. In the previous parabolas that we saw, that was centered around the x-axis, we saw two parabolas, one that was opening to the right and the other one that was opening to the left. So the differences we saw were that you're going to have a negative sign, and that's it. That is the only difference. So just like that, over here if you see, the previous one had x squared is equal to 4py. The next one is just going to be x squared is equal to negative 4py. Just like the parabola we saw that opened to the right and the opened to the left, the only difference was the negative sign, because now it opens to the negative part of the y-axis. That is the negative part of where x is equal to 0. So now before I tell you the properties of this, try to imagine them, try to write it down on the paper yourself, so that when I go to that slide you would know whether you've understood it or not. If you look at this, the first thing is, what is this parabola centered at? Of course we already know it is written, the vertex is 0 comma 0, so this we know. Okay, what about this parabola's focus point? This parabola's focus point, what would that be? Go ahead and write it down. Now this parabola's focus point is going to be 0 comma negative p. Why? Because it is going to be some place over here, and where x-axis is 0, the x value is 0 and the y value will be negative, so it will be 0 comma negative p. On the other hand, where will be the directrix? The directrix would be over here, that is y is equals to p. This I explained to you in the previous slide why that would be. And if you look over here, the directrix is exactly where I told you, y is equals to p, 0 comma negative p is the focus point, and the vertex is that, the origin that we saw. And the axis of symmetry, as we can see over here, is once again the y-axis where the x value is equals to 0. Now, we have already talked about parabolas that open to the right and open to the left. But what about parabola which are basically centered at 0 comma 0? What about parabolas that open to the right, open to the left, but which are not centered at the vertex? I mean, every parabola does not have a vertex at 0 comma 0. So what about that parabola? Well, let's look at the first example over here. So if you look at this, the shape of the parabola, we know that it is opening to the right. This much we know. So after knowing that, what else do we know? We know nothing else about it right now. Of course, if you look at this diagram, we'll see that the directrix is x equals to 1, and because p over here is equals to 2, the p over here is equals to 2, so we know that the directrix is actually 3 points to the left of this. So where would we have the focus? 3 points to the right of it. This is the focus point. Now let's first focus on this one. This parabola is centered at a point called h comma k. H is the x-axis, the new x point, and k is the new y point. This point is known as h comma k. So we have a directrix over here, that is x equals to 1. So we know that the directrix, this vertex is actually equally distant from the focus point and equally distant from this directrix. So the directrix is equals to negative 1. So that would be, once we know that p is equals to 2, we know that from the graph we can see that this is x equals to 1. So one point over here and one another point over here. So the directrix is actually 2 points to the left of the vertex over here, to the left of the parabola over here. So where would the focus be? The focus would be 2 points to the right of it, because it opens to the right. 2 points inside the parabola, if you can understand that. Inside would be 2 points, one over here and one over here, that is 3 comma 2. So this we have over here is a focus point, and this is a directrix. Now this is the new equation over here. What have we done over here? The only thing that we have done over here is that first we had y squared is equal to 4px. Now we have y minus k whole square, yk, because this is a new y offset. This is the new y offset, and that is why we're going to have k over here. We know that the vertex is shifted h comma k. First, this is actually the real equation of the parabola. In the previous parabolas that we read, the thing was that h comma k were actually 0. So if we substitute those over here, y minus 0 is equal to x minus 0. So we're going to get y square is equal to 4p x. That means a parabola that is centered at 0 comma 0, which has a vertex at 0 comma 0. If you want to remember anything, I would say that you remember this equation. Y minus k whole square is equal to 4p x minus h. Why should you remember this equation? Because if you remember this equation, you can just plug in the vertex and you can get the new answer. If the vertex is 0 comma 0, so y minus 0 whole square is equal to 4p into x minus 0. So that's going to give you y square is equal to 4px, just the equation that we studied before. So moving on now. So now we see that exactly the same thing that I told you before. So that is that p is the distance from the vertex of the parabola to the focus of the directrix, which would make the coordinates of the focus h plus p comma k. If you look over here, this point is h comma k, which is the x value, right? H plus p comma h is the focus. We talked about 3 comma 2 being the focus. So h over here is 1, p we know is 2, so this h comma k is the focus, that is 3 comma 2. This is how you find out the focus. You need the value of p, you need the value of h and k, only h basically, but if you have k, then you can find both the coordinates of the focus, and then you have 3 comma 2. Moving on, how do you find the directrix? The way to find the directrix in this is h minus p. H we know is the x-axis, minus p would x-axis value of the vertex, and P we have that is 2, and we get the dialectics. If you look over here, we have H as 1, minus 2 would give us x is equals to -1. This is the value of this. If you try to remember, this is the value of the dialectics. If you try to remember this, it's going to be a lot of stuff, but it's because there are 4 parabolas that we studied before, 4 we're going to study now. So instead of this, just try to remember the concepts behind it. Just try to visualize this through a graph. And in order to find the symmetry, you need y is equals to -b over 2a. Now coming to this axis of symmetry that we need to find. So b and a, you don't see any b and a over here, but we know there are b's and a's over here. What is b and a? We know that the equation of this parabola is going to be ax squared plus bx plus c, with the different values for a, b and c. That's going to give it this curve. So those values of a and b are going to be substituted in this formula, and you're going to get y is equals to -b by 2a as the axis of symmetry. So moving on, now this was the parabola which was not centered at the origin, which opens to the right, and it has this equation. What would happen to the parabola that is not centered at the origin but it opens to the left? What would be the equation of that? Now before I show you, what do you think? There will be just one change. There will be no difference except for one. What do you think that difference would be? That difference would be the negative sign. That difference would be this negative sign over here, and all the other things in the equation would be the same. So this is the equation of the parabola that is not centered on the origin and it opens to the left. That is all the difference there is between these two parabolas. If you look at the next, of course the differences in the next part would change because of the sign, but that is the only thing that's going to change. If you look over here, h minus p, it was over there as well. Now what about this? H plus p plus comma k was the focus, and h minus p was the dialectics. Over here, h minus p comma k, there's minus instead of plus, and it is plus instead of minus over here. This is the same again. Axis of symmetry is minus b by 2a. These are the only differences that you have to keep in mind for these two parabolas, and I think this is pretty straightforward. Now let's look at the other parabolas that open to the right. What are this? What is the difference in that? Just like in the previous example, we saw that instead of y, we would have x to the parabola that opens to the right. That is aligned with the x-axis that had a symmetry of axis on the y-axis. Sorry, x equals to 0. Over here, we have a parabola that opens to the right, which is not centered at the opens up, which is not centered at the vertex. So the difference in the equation will be just the same as we talked about in the previous parabola that opened up. That is that instead of y, we're going to have x. Why is that? Because this is centered at x is equals to 0. So over here we see that over there it was y over here and was x over here. So, and because that it opens up, and that is the difference from the previous one. Now moving on, of course there will be some changes of signs, and if there will be some changes in the equations and in the different formulas. So you see over here, this formula over here, nothing will be added to h, because h is the x-axis over here. It is centered at the x equals to at the y-axis, so we're going to have k plus p over here. And in order to find the vertex, we're going to have y is equals to k minus p. In order to find the directrix, we're going to have y is equals to k minus p over here. Once again, the line axis of symmetry is going to be -b by 2a. So right now, don't focus on why the signs are going to change. Just try to understand how these equations are formed, how these equations are the way they are, why they are like this. So this is the main equation for the parabola that opens up. Moving on, the parabola that opens down. Now what will be the difference between the parabola that opens up and the parabola that opens down? The same distance between the parabola that opens to the right and the parabola that opens to the left. And that difference is this change in this sign over here. Is going to be negative. This whole equation is going to be negative. The rest of that is same. I mean, you look at these two equations, so the only difference is this negative sign over here. So the same would happen over here. Like I told you that there were some changes in the signs and some changes in the values. The same changes are going to apply to this parabola that opens down as compared to the parabola that opened up. And that is over here. We have the focus point h comma k minus p. Over k minus p. Over there we had h comma k plus p. So we have h comma k minus p over here. Over there, in order to find the directrix, we use the equation y is equal to k minus p. Over here we have y is equal to k plus p, and the axis of symmetry is going to be x-axis, and the value on the x-axis, a straight line on the x-axis, and that is going to be x equals to negative b over 2a. So this is pretty much it for parabolas. Just if you try to remember this, you try to rote learn this, there are altogether of 8 parabolas that we learned, and they're all together of like more than 16 values that we learned. So rather than memorizing this, I would say, just like I've been saying before, rather than rote learning, is I would suggest you try to understand the concept of all this. You try to understand why these things are the way they are. Look at the main thing that you need to do is visualize this. The more you visualize this, the more you plot it on a graph, and the more you write down the values and you see them for yourself, the more your concepts are going to be clear. So best of luck with this, and in the next lecture we're going to continue with the conic sections, and we're going to talk about the ellipse. Thank you very much, and hopefully I'll see you again in the next lecture. Bye.